The journey of seafood begins far from the factory, out at sea, where industrial fishing vessels.
Each haul represents hours of coordinated effort at sea. Fish are handled quickly to preserve freshness.
Immediately after capture, fish are chilled to slow bacterial growth. Cold preservation begins before the ship ever reaches shore.
At the port, logistics operate non-stop to receive massive volumes of seafood. Timing is synchronized with factory.
Cranes transfer seafood directly from ship to shore using insulated containers, minimizing exposure to ambient temperature.
Every container is digitally logged on arrival. Traceability links each batch to vessel, location, and catch time. Data follows the fish throughout processing.
Mature. Unloading occurs inside chilled reception zones to prevent temperature spikes. The factory's cold chain begins at the
Crushed ice and sub-zero air maintain low temperatures during transfer. Even brief warming can affect shelf life. Precision cooling is non-negotiable.
From port to plant, seafood moves through enclosed pathways. Exposure to the outside environment is minimized. Speed and isolation preserve freshness. Each batch is weighed immediately upon arrival. Accurate mass tracking supports inventory planning and regulatory reporting. Every kilogram is accounted for.
Real-time weight data feeds directly into the factory's production system. Planning begins instantly. Volume dictates line speed.
Quality inspectors perform rapid visual checks on incoming seafood. Color, texture are assessed immediately.
Core temperatures are measured to confirm cold chain integrity. Deviations trigger rejection or rechilling. Temperature control defines safety.
Incoming seafood is separated by species and size. Different fish require different processing methods. Early sorting improves efficiency. Vision systems identify species and estimate size within milliseconds. Automation replaces manual sorting at scale. Accuracy drives throughput.
Fish that fail initial checks are diverted instantly. Segregation protects the main processing line. Waste is minimized through controlled recovery.
Rejected product is handled under strict controls. Some is reprocessed for alternate uses. Nothing is mixed unintentionally. Improved fish move into washing systems that remove surface contaminants. Cold, filtered water prevents temperature rise. Cleanliness begins immediately.
High-volume rinsing removes blood, slime, and debris. Clean surfaces protect cutting equipment. Hygiene supports efficiency.
With intake complete, fish transition into the heart of the factory. From here, automation dominates. Processing accelerates.
Food-grade stainless steel defines every surface. Cleanability and corrosion resistance are essential. Design supports sanitation.
Buffer storage balances intake with processing speed. Temperature remains tightly controlled. Flow stability prevents bottlenecks. Uniform cooling prevents hotspots and spoilage. Even weighting is engineered. Control never stops.
Primary processing lines operate in parallel to handle enormous volume. Each line is specialized. Scale demands duplication.
This marks the transition from intake to full-scale processing. What follows is high-speed transformation driven by robotics and precision.
Primary processing begins as fish are fed into multiple synchronized lines. Each line is calibrated for species and size.
Precise alignment is essential before automated cutting begins. Guides adjust position within milliseconds. Uniform orientation enables robotic accuracy.
Automated heading machines remove fish heads with clean, repeatable cuts. Blade angles are species-specific. Precision reduces waste and improves yield.
Separated heads move immediately to byproduct streams. These materials are reused for fish meal or oil.
After heading, fish enter automated gutting units. Robotics remove internal organs rapidly and hygienically.
Vacuum-assisted tools extract organs without rupturing tissue. Clean removal protects meat quality. Tool geometry matters at this scale.
Extracted material is transported through enclosed systems. Separation prevents cross-contamination. Hygiene remains uncompromised.
Internal washing removes residual blood and debris. Cold water preserves texture and color. Clean cavities prepare fish for filleting.
Targeted sprays reach internal surfaces thoroughly. Flow rates are optimized to clean without damage. Water management is critical.
Post-gutting inspection verifies cleanliness and cut accuracy. Both humans and machines assess quality. Standards remain strict.
Machine vision identifies imperfections invisible at speed. Any defect triggers automatic diversion. Technology enforces consistency.
Fish are graded by size and redirected to matching filleting lines. Size uniformity improves cutting precision.
Data-driven grading informs downstream operations. Adjustments occur instantly.
Information drives flow.
Before filleting, fish bodies stabilize briefly to align muscle structure. Controlled motion improves cut quality. Preparation enhances yield.
Straightened alignment ensures fillet symmetry. Even minor bends affect final shape. Precision begins before the blade. Robotic filleting systems self-calibrate based on incoming fish size. Sensors adjust blade paths dynamically. Automation adapts in real time.
Laser mapping identifies bone location and muscle thickness. This data guides every cut. Vision replaces guesswork.
With preparation complete, fish move into full filleting operations. Speed increases dramatically. Precision becomes critical. Blades position with sub-millimeter accuracy before cutting. Timing and alignment determine yield. Robotics excel here. Frames and trimmings are collected separately for secondary processing. Nothing is discarded casually. Utilization maximizes value.
At full capacity, dozens of filleting robots operate in parallel. This is industrial seafood processing at
real-time metrics confirm continuous flow. Performance is monitored constantly. Data ensures targets are met.
Fillets now move deeper into the plant for refinement and inspection. The process continues seamlessly. Integration defines efficiency.
Temperature control resumes immediately after cutting. Cooling preserves freshness and texture. Cold chain continuity remains vital.
Primary preparation is complete. What follows is precision trimming, inspection, and packaging at scale.
Robotic filleting is where speed meets anatomy-aware precision. Each machine executes thousands.
Laser maps guide blade paths around bones and pin structures. Algorithms adapt instantly to size variation. Vision replaces manual judgment.
Lean separation minimizes tearing and waste. Fillets are routed forward without interruption. Flow stability protects texture.
Secondary robots refine edges and remove residual bones or skin. Fine trimming improves appearance and portion uniformity. Detail work matters. Force sensors prevent overcutting and preserve muscle fibers. Pressure adjusts dynamically. Intelligence protects quality. Automated pin bone removal targets remaining microbones precisely. Clean removal enhances consumer safety. Automation scales delicacy. Vision systems assess color, shape, and surface integrity at speed. Defects are detected instantly. Standards remain uniform. Artificial intelligence flags inconsistencies invisible to the naked eye. Decisions occur in real time. Data drives acceptance. Non-conforming fillets are diverted without slowing production. Segregation protects the main flow. Waste is minimized. Inline weighing verifies portion targets instantly. Accurate weights support pricing and labeling. Compliance is enforced automatically.
Every gram is recorded and tracked. Data accompanies each fillet downstream. Transparency supports traceability.
Chilling stabilizes temperature immediately after cutting. Rapid cooling slows microbial growth. Timing preserves freshness.
Sensors convert targets before the next step. Control prevents temperature abuse. Cold chain discipline continues.
For frozen lines, a thin glaze protects fillets from dehydration and oxidation. Even coating is essential. Protection extends shelf life.
Controlled drainage prevents ice buildup. Balance maintains appearance and weight accuracy. Precision governs finishing.
Post-glaze inspection confirms coverage and appearance. Visual purity remains critical. Checks never stop.
Environmental control protects surface quality. Condensation is avoided. Systems work together.
Alignment prepares fillets for high-speed packaging. Uniform spacing prevents jams. Preparation reduces errors.
Guides adapt instantly to size variation. Automation anticipates change. Flow remains smooth.
Air barriers maintain hygienic separation between zones. Clean design enforces discipline. Safety is engineered. Everything entering packaging is sanitized. Continuous cleaning reduces risk. Hygiene is constant.
Packaging systems stand ready for sealing and labeling. Speed will increase again. Protection and presentation take priority.
Materials are selected by product type and destination. Preparation supports efficiency. Details matter.
Final checks confirm settings for seal strength and gas composition. Accuracy prevents waste. Readiness is verified.
Filleting and finishing are complete. The final phase, packaging, storage, and distribution, begins now.
Packaging begins at extreme speed as robots place fillets with perfect alignment. Consistent presentation supports.
Protective gas replaces oxygen to slow spoilage. Gas ratios are tightly controlled. Packaging becomes preservation.
Heat sealing locks the product inside a sterile barrier. Seal integrity determines shelf life. Every seal is verified.
Leak detection confirms package integrity in milliseconds. Even micro leaks are rejected. Zero tolerance protects consumers.
Defective packs are removed instantly without slowing the line. Continuous verification sustains throughput. Automation never pauses.
Check weighers enforce declared net weight at speed. Compliance is automatic. Accuracy builds trust.
Labels carry nutrition, origin, and handling data. Placement accuracy ensures scan reliability. Information travels with every unit.
Unique codes enable full traceability from shelf back to vessel. Documentation is built into the product. Accountability is continuous.
X-ray systems scan sealed packs for foreign materials. Safety layers overlap. Protection is non-negotiable.
Algorithms analyze density patterns in real time. Any anomaly triggers rejection. Safety operates invisibly.
Rapid chilling or freezing stabilizes quality immediately. Speed preserves texture and flavor. Temperature control defines shelf life.
Uniform airflow prevents freezer burn. Controlled icing protects moisture. Precision matters in the cold.
Robos group units into shipping cartons with perfect geometry. Consistent stacking prevents damage. Efficiency scales logistics.
Reinforced seals secure cartons for long journeys. Packaging must survive vibration and handling. Durability is essential.
Palletizers build stable loads optimized for transport. Pattern engineering maximizes strength and space. Robotics ensure repeatability. Stretch wrap locks the load against moisture and movement. Stability protects safety. The pallet is shipment ready. Finished pallets enter cold storage where temperature and humidity are tightly regulated. Storage preserves value. Inventory flows digitally.
Real-time tracking accelerates fulfillment and prevents errors. Data orchestrates movement. Logistics stay synchronized.
Refrigerated transport maintains the cold chain to markets. Breaks are unacceptable. Distribution connects factory to consumers. From one facility, thousands of tons move monthly. Scale depends on coordination. Logistics makes seafood global.
At retail, clarity and freshness are visible. Packaging communicates trust. Presentation completes the journey.
Consumers see a simple pack. Behind it lies a vast engineered system. Transparency builds confidence.
Robotics handle thousands of precise actions every minute. Consistency replaces variability. Automation defines scale.
Data confirms performance at industrial magnitude. Metrics tell the story. Efficiency is measured.
This is how 5,000 tons of seafood are processed every month through precision, cold chain control, and relentless automation.